Hello everyone, this is the third video of decision trees with R. And in this video, in order to evaluate model performance independent of the cutoff value, we will examine the cumulative lift chart, the decile-wise lift chart, and the ROC curve. We first need to convert target variable, if you remember, it's HELOC, to a numerical data type as required by the gains package using as.numeric function. We generate the cumulative lift table using the gains function. The gains function requires two inputs: actual class membership and predicted target class probabilities. So because 1 is the target class, we refer to column 2 for the predicted target class probabilities. So therefore, let's enter our code to get the gains table. So here we type validation set, and from that data set we choose HELOC, and that's equal to as.numeric because we want to get HELOC as numeric, and in the parentheses as.character, and again we are going to choose validation set HELOC, and then select Control Enter. Next, we are going to title our gains table, gains underscore table is equal to gains function. In gains function, again, we need to determine which data set we use. We use validation set, and here we are going to choose HELOC, which is our target variable. And from predicted prob table, we are going to get the second one because the predicted probabilities are on the second column for the target variable, and then Control Enter. And next we can type gains underscore table to be able to see the table, and then we Control Enter. Now on the screen under console pane you can see the cumulative gains table. Because there are only 3 possible target class probabilities in the pruned tree, which in this case are 0.55, 0.35 and 0.11, that can be assigned to each case. The gains function generates only 3 groups instead of the default 10 groups, 1 for each unique probability value. And also note that these values are rounded to 2 digits after the decimal point. That's why you will get the warning on the console pane that says fewer distinct predicted values than groups requested. After we get our cumulative gains table, the next thing that we do is to create our performance charts. And for R, the instructions to create cumulative lift chart, the decile-wise lift chart, and the ROC curve doesn't change. So what we are going to do is that we are going to copy the performance charts from another R script. Here on the screen, you see that for cumulative lift chart, we use this following lines of code. Decile-wise, we use this code, and ROC curve we use this code. So what do you need to change for this code? The first thing you need to change is the target variable. Whenever you see target here, it needs to be your target variable. For our case, it's HELOC. So I'm going to change all target instead of target here. I will replace it with HELOC. And the second thing you need to change is the gains table. If you title your gains table with a different name, then you need to change it here. I title it as gains underscore table. That's why I have gains underscore table in this code. And finally, you need to change the predicted prob. If you title it differently, then this needs to change, and it's going to be replaced with the title you choose for your predicted probabilities table. So let's copy this here, and then let's write it here, performance charts, and we are going to start with cumulative lift chart. And as I said before, I don't need to change gains table because my gains table is gains underscore table, so I keep it, but I need to change here HELOC, and gains table here is correct. And again here in the second line of code, you have to change it to HELOC. And here in bar plot, gains table stays the same. We need to change target to HELOC. And here on the ROC curve, we need to change target to hello. And predicted probabilities table, I'm not changing the name because this is exactly the same title that I have for my predicted probabilities table. And let's select this code and then control enter. Now you see on the screen under plots pane the cumulative lift chart. This chart shows that the classification model shows superior predictive power compared to the default model. The bank can reach a larger portion of potential customers who will actually respond to the HELOC offer by targeting a smaller percentage of potential customers with the highest predicted probability of responding to the offer. Next, let's do the decile-wise lift chart and select and control enter. Now you can see under plots pane decile-wise lift chart. If the bank sends offers to the top 21% of the potential customers with the highest predicted probability of responding to a HELOC offer, it would be able to capture twice as many individuals who actually respond to the HELOC offer as compared to if 21% of the customers are randomly selected. So I hope this is clear. If you select 21% top highest predicted probabilities of accepting the offer, then you have twice as many chance than a baseline model which you select 21% of customers randomly from the same dataset. So that's why it's important to check both cumulative and decile-wise lift chart. And let's do the ROC curve, control enter. And finally you see the ROC curve under plots pane. Again, this curve shows that the classification tree model outperforms the baseline model in terms of sensitivity and specificity across all cutoff values. And when you look at AUC value, which is area under the curve, 0.7395 also reinforces this finding. Finally, to score the 20 new cases, we need to import the data HELOC_score into a data frame and called myScoreData, and then use the predict function to produce the predicted class membership and probabilities for the new cases using our classification tree. So first, let's get the data. I'm just going to copy this because I have already ready code here. And now this time it's going to be myScore, and I'm going to read that HELOC.score from my working directory and control enter. Next, I'm going to type here predicted_class_score is equal to predict, and here we are going to use our pruned tree. And next, myScore, and then type is equal to class, but the class needs to be in quotation mark. And then select and control enter. And we can see predicted class score variable, control enter. And then next, predicted class prop is equal to predict, open the parentheses, pruned tree, myScore, and then type prop and control enter. And finally, predicted class prop and control enter. So the scoring results are summarized under console pane. So in the prediction, the 5th customer is considered as going to accept the offer. So let's look at the 5th one. The probability is 0.666, and then also the 11th one, again probability 0.66, and then 15, and then 17, and then 18, and then 20. So this is how you do decision tree model using R. Thank you for watching this video.